Anyways, it says write a linear equation in one variable that has no solution. All right. It says you could use a strategy of working backwards. So what you could do is you know that it has to have a false statement, right? So if it has a false statement, you start with, and I'm going to write this over on the side. You can too. Sometimes I think that it helps. So if I say, all right, 3 equals 5, that's false. And now I'm going to add x to both sides. So on the next line, I'm going to say x plus 3. And that's fine as long as I do it to both sides. And x plus 5. Now they wrote it this way for whatever reason. Doesn't matter. And then it says, next, add the same constant to both sides. What do you guys want to add? How about we add 7? So if we add 7 to both sides, I can do that. And then I get x plus 10 equals x plus 12. Then it says, verify that your equation has no solution. So if I say x plus 10 equals x plus 12, and I try to solve it, I would subtract 10 from both sides. That's cool. And I'm doing it different than they are, just to show you that you'll get the same thing. 10 minus 10 is 0, 0 plus x is x. Then over here we get x. 12 minus 10 is positive 2, so we say x plus 2. Now what do I need to do? Well, I need to move this x over here. So I'm going to subtract x on this side. Whatever I do on one side, I have to do to the other. Over here, I get 0 plus 2 is 2. Over here, I get 0. That's false. When it's false, you have no solution. See how that worked? So it says, explain why the result of the process above is an equation with no solution. Simply put, it started with a false statement. So math is actually a language in the sense that we make a lot of statements and we follow a bunch of rules to make sure the statements stay true. We don't talk about that in middle school and high school, but I mean, if you go to even at an undergraduate level, towards the end there, they start to talk about true statements. So everything in math that we do has to be true. Sometimes when you do things, it's false. So all these rules, add on both sides, distribute this. We do those things because it makes the statement true. The left-hand side is equal to the right-hand side. So that's how it works in math. And so that's a statement. When it's false, in other words, the left-hand side doesn't necessarily equal the right-hand side, well, then the math doesn't work. So when we make an equation with a statement that started as false, you can't take something that's false and make it true. Does that make sense? You have to start with a true statement and then continue to follow a bunch of true things, and then you'll end up with a true. But if you have something that's false, let me give you a better example. I am wearing a pink shirt. Bubblegum pink, if that makes you feel better. I'm wearing a pink shirt. Now, clearly, when you look at me, I am not. But I could say I'm wearing a pink shirt, I have a beard, and I can add a bunch of true statements. But when I ask you if what I said was true, what would you say? No, it's false because I don't have on a pink shirt. And that's what we did here. We started off with this, which was false, and then we did a bunch of true stuff. Because I added 7 to both sides, adding 7 to both sides, in other words, positive 7 is equal to positive 7, that's a true statement. Negative 10 is equal to negative 10, that's a true statement. And so all these things that I'm doing may be true, but since I started with false and I did a true thing, if I reverse the process, I do a true thing, at some point it's going to end up being false. Does that make sense? Okay. If I say, well, one or two kids shaking their heads no. Let's just keep working on the examples, and hopefully some of this will click. Okay.